สวัสดีครับ now we move to the chapter 5. It is about the law of motion. So far we have discussed the motion of the particle under the assumption that we know the acceleration of the particle. In this chapter we will look at the cause of the motion, or maybe more precise, we will look at the cause, what make the object move with an acceleration. We will first introduce the concept of force, which is the cause of the acceleration of an object. Next, we will introduce the law of force, which is the Newton's law of motion. We start with the first law, in which we define an inertial frame of reference. The concept of mass is then introduced, and then followed by the Newton's second law, which relates the force, mass, and the acceleration of an object. One of the most important force is the gravitational force. This force is closely related to the concept of the weight of an object. Next, we discuss the Newton's third law, which tells us that where there is an action force, there is an reaction force. In the problem of the dynamic of a particle, the second law seems to be the most important. So, we will introduce the general strategy to apply the second law to the problem of the dynamic of the particle, and this will be discussed in this section. And we will end this chapter by discussing the frictional force, the force that we experience in everyday life. Okay, so now let's start. We start with the discussion of the concept of the force. The word force refers to an interaction between an object with the environment. We can write that force is the interaction between the object and the environment. From our experience, we know that as the nature of force, it will tend to change the velocity. Tend to change the velocity. However, it does not mean that when you apply a force to an object, it will move always. Sometimes we apply the force to to the object, but it did not move. But we know that the force will tend or will try to change the velocity of an object. In general, we may say that there are two kinds of forces. First is the contact force, that is, the force that comes from the contact between the object and the environment. For example, when you pull the spring, you exert the force to the spring, and it comes from the contact between your hand and the spring. This woman pull the cart, and she exerts the force to the cart by pulling the string here. So this is the contact force. A football player kick the ball, and when he contact the ball, he exerts the force to the ball, and this is also the contact force. The second kind of force, we may call it the field forces. It means that we do not need the contact between the two objects that exert the force. For example, the gravitational force, we can have the gravitational force without contact. The electric force that we will study next semester, the charge can send the force to the other charge without contact. The magnetic force is also the non-contact or the field force. Humans know the force for a long time, but it is Isaac Newton. It was Isaac Newton who gave us the law, the mathematical law that we can describe the force and the relation between the force and the motion. And by his law of force, together with the universal gravitational force law, he can explain most kind of motion, from the small object near the Earth's surface to the motion of the star. Okay. We physicists regard him as the greatest physicist for all time. Now, let us discuss one of the most important nature of the force. That is, the force is a vector. It means that it has the property of vector, especially when you want to add more than one force together. You have to use the vector sum rule. For example, if you have a spring balance here, and you exert the force F1, next you exert then you exert the other force F2 to the spring. If you exert F1 and F2 together, and if the force F1 and F2 point in the same direction, you can add the magnitude of F1 and F2 together, like in this picture. But if the direction of the F1 and F2 are not the same, you have to use the vector rule of addition to add these two vectors together. This is true both for the magnitude of the resulting force and the direction of the resulting force. Please note that this is the experiment. It is an experimental fact. It is not the mathematical fact, but it is an experimental fact that we know from the experiment that the force is a vector. So this is very important. We have to treat the force as a vector, It means that we have to take care both the magnitude and the direction of the force. We can now start the discussion of the fourth law. Let us start with the Newton's first law. The Newton's first law states that, if an object does not interact with other objects, it is possible to identify a reference frame in which the object has zero acceleration. The keyword here is about the reference frame. As we discussed before, if we want to describe the motion of an object, we need to define the reference frame. The problem is that each observer can define their own reference frame. So which one is the most appropriate? The Newton's first law tells us that the most appropriate reference frame is the frame that when an object do not interact with other objects, the acceleration due to that frame is zero. And we call this frame of reference as the inertial frame, the inertial frame. So, we may say that the Newton's first law is a definition of the inertial frame, and you can see that we use the plural here because the inertial frame is not unique. You can have two frames that move with the constant velocity relative to each other, and if one frame is an inertial frame, the other is the inertial frame too. We will discuss this later. Okay. So from this meaning of the first law, we can state the first law in a different way. That is, in the absence of external force, and when viewed from the inertial frame or inertial frame, we can also write it as an inertial frame. An object at rest remains at rest, and an object in motion continues motion with a constant velocity. That is, when a constant speed in a straight line. It means that the constant velocity means it is a constant speed in a straight line. So if there is no force, an object will preserve its state of motion. That is, it will preserve the velocity. It will remain at rest relative to the inertial frame. This is important. We have to choose the inertial frame first, and we can say that relative to the inertial frame, if there is no force, a particle will remain at rest or move with a constant velocity.